Okay, guys, it's 1, so I'm going to stop sharing and Catherine's going to introduce our webinar series.
Perfect. Okay. Hello, everybody. So welcome to our GrowON webinar today called Japanese Flower Thrips, a New Pest of Flowers. So my name is Catherine Russell. I'll be your moderator for today. I might be a new face to some of you. So I was hired earlier this year as the Greenhouse Floriculture Production Specialist with the Ontario Ministry of Agriculture, Food and Agribusiness. So just a little bit about the GrowON educational series. So this is a series run by the greenhouse team here at OMAFA, and we do both webinar and in-person events such as lunch and learns. And we cover both production topics such as nutrient management, growing media or lighting, as well as integrated pest management topics like we're here to talk about today. So just some general housekeeping to go through. This webinar is being recorded. You'll be able to get the recording off of the On Floriculture YouTube page, which I'll drop the link to that in the chat once we get going here. And we will welcome questions after the speakers are finished. However, if you'd like to ask a question, please do it through the Q&A function on Zoom. Please don't pop it in the chat because sometimes we can lose track of those and we don't want that to happen. So just use the Q&A function, please. And we'll just start off with a quick land acknowledgement here. So to begin our time together today, I'd like to share an acknowledgement of the land where I am today here in the Niagara region, and I'd invite you to consider the traditional territories where you are located as well. The Niagara region is situated on treaty land. This land is steeped in the rich history of the First Nations, such as the Hattie-Wendoronk, the Haudenosaunee, and the Anishinaabe, including the Mississaugas of the Credit First Nation. There are many First Nations, Métis, and Inuit from across Turtle Island that live and work in Niagara today. The regional municipality of Niagara stands with all Indigenous peoples, past and present, in promoting the wise stewardship of the lands on which we live. So without further ado, I will introduce our two speakers today. So first we have Dr. Sarah Jandricic, my counterpart here at OMAFA. She is the Greenhouse Floriculture IPM Specialist. So today, Sarah will be going over a little bit about some ID of this pest, some biology, the host plants, and a little bit about how worried or not worried you should be about this pest. And next we have Judy Colley, a very familiar face to many. She is the technical lead for plant products. And she's going to talk a little bit about the damage that this pest causes, the greenhouse trials being conducted, and some chemical controls that are available. So take it away, ladies.
Okay, I'm just gonna share my screen and make sure all the fun controls are hidden. There we go. So scooch this up here. All right. Okay. Today we're going to talk about Japanese flower thrips, as Catherine mentioned. And today is really more of like a PSA. There's not a lot of research out there about this pest because it is fairly new. Even in Europe, it's only sort of been around for the last 10 years. So Judy's got a lot of hands-on experience that she's going to talk about today, working with commercial growers, and I've sort of combed the literature for different strategies that are out there in the biology and stuff. So we just want to keep you informed. But as Catherine said, the sort of overarching theme of our webinar today is yes, it's a new thrips, but don't panic, and we'll get more into that soon. So in terms of why we're seeing so many new thrips, we talked a little bit about this when we talked about Parpus finus and also in our Thrips ID workshop. The list on the right of your screen in green is all the different thrips species we found in Ontario greenhouses over the past 10 years since we started doing survey work in 2016. And it's really for a variety of reasons. So obviously like an increase in global trade, obviously when we had COVID and there was like a lot more interest in foliage houseplants and everybody had their little houseplant babies, including me. That sort of tropical foliage boom means we're getting different tropical pests in that we haven't really seen before. You could also blame a little bit of climate change for this because insects are expanding their ranges. So insects that might have been perfectly happy staying in, Asia or Indonesia or places like that before are now coming to Florida and being like, huh, this seems like a good vacation spot. Maybe I'll buy some property here too. And then we always have things like, deregistration of harsher pesticides, or just, us not using harsher pesticides to keep our biocontrol programs for other pests going. So obviously, if you're not using as many sort of these, blanket pesticides that can kill a lot of different things, that means more things can move into your greenhouse and set up shop. And I would say lastly, it's just increased surveillance since we just started doing that survey work in 2016 and realized that we were having, not just Western flower thrips on the scene, but onion thrips. Then people started looking, and then we found more things than onion thrips. So, and Judy's been one of our favorite lookers, I guess, of always bringing us fun little samples, gift wrapped for Ashley Summerfield, who really likes to ID thrip species. So, but the more we learn about these things, the more we can recognize them and do something about them. So I think that's why we want to share this information with you, so you know what you're looking at and know what to do about it. So I did mention a bit where this pest comes from, typically from Eastern Asia. The first record was found in Japan, but that doesn't mean it's necessarily like that's where it evolved, but that was the first record in 1928. And in Japan, it's mostly a pest of greenhouse vegetables. And then it moved over into Europe. I believe it was found in France first, but then in the Netherlands shortly after in 2024. And it's interesting because in Japan, it's pest of vegetables, but in the Netherlands and France and those countries, it's actually a pest of almost exclusively hydrangea. And they can't really say what that host shift is from. It could be from different IPM practices. It could just be like, oh, we haven't eaten a hydrangea before, and these are awesome. Yeah, chemistries, yeah. So one thing about it is that once it was found in Europe, it was originally put on their sort of alert list of harmful pests that they have in Europe called the EPPO. But they removed that in 2018, basically because they considered it not that harmful and not a quarantinable worthy pest. So that might give you some hints about whether you should panic or not. And then it was found in North America in Michigan in 2016. So that greenhouse was quarantined by USDA APHIS. However, I have spoken with that grower when I was at the Great Lakes Conference run by Michigan State University a few years ago. And it wasn't, a year-long quarantine of all their farm locations. It was sort of like 3 to 6 weeks, I can't quite remember. And they had to do some pesticide applications to prove that they'd eradicated the pest. And I think they also threw out some plants. But after that, then it was sort of like business as usual. So it could have been worse. As far as how that affects us, we did find Japanese flower thrips or thrips setosus. I'm going to kind of bounce back and forth between those names. We found it in Ontario in 2021 from hydrangea. And in terms of our own regulatory bodies, we did go through the proper channels through the National Identification Service in Ottawa, and then they let CFIA know that it was a new find for Canada. But at that time, we didn't really have any response from CFA. That doesn't mean they couldn't change their mind, but that's sort of where we stand right now. And then also important for us, though, is that it is still on the USDA's regulated pest list. You can go to the 2025 list now online, and along with Thrips parvispinus and chili thrips and a few more thrips species on there. So if it is on that list, then that means if an inspector were to find a shipment at a border with a bunch of dark thrips that they aren't really sure what they are, they could stop the shipment and send thrips for ID. And then also because Thrips parvispinus is on that list and they do look a lot alike, which we'll talk about after, that poses even more of a problem. So just FYI, this is the kind of pest you want to clean up before you ship over the border. And that's basically like the scariest part of it right now, I think, is just making sure you've got a clean crop before you ship to the States.
So some of the distinguishing features when you're looking at them in the greenhouse, just quickly, the head and thorax are generally a little bit lighter than their abdomen. And when you're looking at them quickly, it is a dark thrip, but their wings they're clear, but it kind of gives a silvery shine to them when you're looking at them. So when you see it crawling on a hydrangea, for instance, you'll see kind of it looks like a silver to a clear stripe, and that it's sort of in the middle of their body. And if you take them home and you pickle them in alcohol right away, it sort of causes them to elongate, and then you can see the distinguishing features a little bit more clearly. And then the red ocelli aren't distinguishable; they're sort of bleed together, but they do look like a lot of other dark thrips species, dark western flower, dark onion, parvy, and the list goes on. So we know they're able to survive outdoors in our climate if the winter is warmer, and also they can overwinter in coolers, because we find them again in hydrangeas in the spring when they start to warm up the greenhouse. So far, they're less likely to develop insecticide resistance, and we're going to talk about this later on, because you don't want to build up resistance for this thrip, because right now it is being controlled. It does pupate in the soil and on the foliage. There's a lot of conflicting literature about that. Some say only soil, some say only foliage, but it can do both. It doesn't really feed on the flowers. It can be there, despite the name, and it does not feed on pollen, which is handy for a bioprogram if you're using Nutrimite or you're applying pollen for your beneficial insects. This one will not go through the roof with population. So some of the hosts that we know, we first started seeing them in hydrangeas, but now we have found them in some other crops. We know there's 14 different plant families that can have Japanese flower thrip, but definitely in Ontario, we've seen them in hydrangea, hosta, cyclamen, greenhouse veggies, and ipomea, some other annuals like Lysomachia even. So again, it's kind of one of the ones that you sort of want to determine which one it is, and that'll determine how you're going to control them.
Yeah, and one thing they pointed out in the literature with this host range was this is just hosts that people somewhere have reported them being on. But Judy and I were talking about this yesterday about how there's a difference between host plants where the thrips can actually reproduce on them, like lay eggs and have larvae and do a whole generation. And then there's the boop hosts where the thrips will maybe be on hydrangea and then boop over to one of these other plants and be happy feeding on it. So you might find it on it, but it's not a true host in the sense of it can reproduce. So I think a lot of these things that we see on these lists, like I feel like chrysanthemum gerbera end up on every thrips list.
Yeah.
And it's like, we know, like parvy doesn't really care about any of these very much. So I would be hard pressed to think that Japanese flower thrips would actually reproduce on all of these, but these are ones to watch, I suppose.
Yeah, because we still have to identify this, so we've just started, so definitely it's worth a look. And this slide is actually a picture of one that's been pickled, and you can see how it's stretched, and so you can see the white banding. It's much more evident, especially if you're trying to determine whether it's a kinothrip or not. When you pickle a kinothrip, it's really orange, so it's obvious. And again, found it on hydrangeas first, and then we found it on some tropicals, some herbs, annuals, and flowering strawberries and things. So it's found mostly on the leaves, but and it has a wide host. So, and one of the other things that can happen, it can transmit the virus. So this is why we're always nervous about thrips.
Yeah, and I think that was recorded in Japan on greenhouse vegetables, the TSWV, but like things like chrysanthemums and other ornamentals can get that virus. So that's why we sort of need to be careful. And I also enjoy the idea of Judy walking around with little Ziploc bags full of pickled thrips, which I happen to know she does.
Yes.
So if you ever want to ask her how she's collecting them and doing that, she can probably just whip them out of her pocket. So.
Yeah. I always have it in my car.
Yeah.
Yeah.
So we mentioned before that these can look, of course, my head's over this one picture. Let's see if I can move this and it'll be on the recording. So we mentioned before that they look very similar to Thrips parvispinus. So this is a picture Ashley Summerfield from Vineland Research took of parvy and setosus side by side. And you can see very, very similar. The one sort of difference you may notice, but these are, slide mounted specimens with their wings out, is that parvis spinus, the head and thorax are a little bit lighter than the abdomen. And that's true in setosus as well, but it's not as drastic. And then also that's not always true. The color seems to depend a lot on temperature. So this picture to the right on the leaf, that's also a setosus. But if you had just sent me that picture, I might think it was a Thrips because it's so dark, like the whole body. And that probably has to do with temperature because cyclamen tend to be grown at lower temperatures than other crops. So they do look very, very similar, including, as Judy said, the red ocelli or primitive eye spots on their foreheads that are very, very red, almost like a hot pink red. And they bleed together to sort of form this little horseshoe. They have those clear bands on the wings, which I like to refer to as shoulder pads, like they're wearing white 80s shoulder pads. And then the other thing they have in common is, unlike a lot of the Thrips species we deal with, they actually have something called sexual dimorphism, which means the males look different than the females. So these females are all very dark, but their males are light. They almost look like skinny little silly
Clear things.
Yeah, like they almost look like larvae with wings on, like they're very tiny, you know what I mean? So they almost look like a very small like onion thrips, and you're like, oh, is this two Thrips species in here?
Yeah.
But no, it's just like a silly little male of these species. So that is something that can help you tell them apart from something like a Thrips where the males are the same color. So another thing that might sort of tip you off of what you have, if it's parvi or setosis, is the number of males. So again, this is a photo taken by Ashley at Vineland, where we actually have pictures of males because we do see them a lot with parvis spinus. And then you can see the setosis picture. It's just like, there's a female. We don't have a picture of a male. We know they're yellow, but we don't really see them or collect them. So this picture in the flower, this is from a grower growing mandevilla. And every time you sort of open a flower, you will see males and females together. You might have a higher ratio of females, but the males will be in there. So we often see them. But interestingly, if you look at the literature, and then I asked Judy if this is what she was seeing in the field, for Japanese flower thrips, they do make males, but for some reason the ratio is a lot lower. Like the sex ratio is something almost like 99% females and like 0.07 males or something like that. So they do exist. It's just you're probably not going to find them as easily. So if you do if you're looking at a tropical crop and you're seeing yellow and dark thrips, I would say it's probably more parvis spinus. And if you're seeing more dark thrips, then a higher chance that it's setosis. And then obviously I'm going to move our heads back over. The other thing that they obviously differ on is damage. You guys have seen our very long webinar on parvis spinus and all the damage it can cause, but parvis spinus has that really like high scarring factor that can almost form this like brown corking effect on certain tropicals. They really go for the new growth, and plants will just stop growing, especially anything that trellises.
Like boron deficiency.
Yeah, and also can look like broad mite damage in terms of the tissue distortion. And this is true in like obviously something like mandevilla, which is shown here on the left, but on the right, that's poinsettia. And you still see that really heavy tissue distortion and just like the bonkers level of like feeding scars. And I would say the only example or only exception to this is some hibiscus and annuals. The parvis spinus feeding damage can look a bit more like traditional Western flower thrips damage, but most of the time this tissue distortion is like a pretty good factor. And then Judy will tell you what setosis damage looks like.
Yeah, so when you're walking hydrangea crop, you can see the bronzing on the leaves. Sometimes from a quick glance, it looks like sunburn. But when you look close up, it does have quite a bit of scarring. And that's the other picture on the right is the bottom side of the leaf. And there's a lot of frass in the collection. And you can see that it doesn't take many thrips to make that much frass. So there's only one thrip in that picture. And then the other, this is another picture of one that I took. Again, it's a little bit heavier damage, but you can see the damage is on the top as well, and also frass in the scarring on the top of the leaf. And the little guy on the right, if you can see it, when you quickly look at it, it's evident then you can see that white, sort of the banding on their wings, which really makes them stand out, like they almost look like it's a metallic kind of glow at you. So that sort of triggers me a little bit too, whether it's Japanese flower thrip or parvi,
Yeah,
for instance, kind of thing. But
and
yeah,
I feel like you don't see this much poop.
yeah, it's not as these
It's
guys
like
are dirty.
Yeah.
Yeah. These guys are definitely a little bit more dirty.
So the other thrips you may mistake them for, just so we're, we've run the gamut, you've got, different dark thrips in your brain. The other two you could mistake them for.
Just to confuse you.
Yeah, just to confuse you. Again, we'll move our hands over just a little bit. Okay, good enough. The other ones could be like echinothrips or vandathrips. But there's some, again, things that'll tip you off that you're not dealing with these. So the first of all, like echinothrips is larger, but that's all relative, right? Like when you're seeing a thrips on its own, not next to another thrips, what does a large thrips mean?
Yeah.
But the other thing that Judy mentioned before when she was talking about pickling is echinothrips and vandathrips. They have that, what I like to call a red jelly center. So that they have red pigment in between their like body segments.
A necklace and a bell.
Oh, there you go, necklace and a bell. Whereas Parvis finus and Japanese flower thrips, they just have a beige filling, so like coffee, caramel, whatever donut filling you like. And then behaviorally, echinothrips are really slow, whereas like we don't find that with any of the other thrips. So like setosus is pretty fast moving. Parvis finus, Judy and I talk all the time how we get hit in the face with them because they like to jump. And then echinothrips obviously pupate on the leaves almost exclusively, and all the other ones pupate in the soil except for Japanese flower thrips, which, as Judy says, does both. And then your other tip-offs will be the host and the damage. So vandathrips, for example, it's only on orchids. So if you find a dark thrips with shoulder pads and red jelly filling, it's probably going to be vandathrips. On
wider.
Yeah, they're a little bit wider, their body. Yeah, they're not as skinny, they're not as delicate. They're sort of, chunky bears. And then for where they feed, echinothrips really likes, they pretty much feed on foliage only, and they really like the lower leaves, whereas Parvis finus, as I mentioned before, likes the meristems, the growing tips, the trellising little leaders. And then Japanese flower thrips feeds on all parts of the plant, as Judy mentioned. So anything else you want to add to?
No, I think
part?
that's good.
Yeah.
Sometimes though, like the one picture here, it looks like Japanese flower thrip have brown eyes. That's not always the case.
Yeah,
So
I think it's just
it's just the picture, probably how the light was shining on it with the microscope.
yeah, absolutely. And sometimes if they are very dark, like it is really hard to see the ocelli, the red ocelli, like on something like echinothrips because their body is so dark. So Japanese flower thrips, that could also happen again if they're taken from a crop where it's grown cool. If their body turns darker, then you're going to have difficulty seeing those red ocelli. Even under a microscope, we struggle with that sometimes. So.
Hydrangea in the wintertime, definitely it's hard to see.
Yeah. So identifying thrips species, if you've been to any of my webinars or workshops in the past couple of years, you know that we've been harping on hoping to get growers to ID their own thrips species up to a point. So we developed this simple key to important thrips pests of Canada, and this includes the invasives that we see all the time. It does require a microscope. We have some videos online, so Catherine can pop into the link, or pardon me, into the chat, the link to our latest version of the key. And then she'll also look on floriculture and look for our video on how to pick a microscope. And microscopes have really gone down in price. So it used to be really like cost prohibitive, or only like, Judy or myself would have one, and that's pretty much it. But really you can buy a great one for between $200 and $300 now.
That'll those little $40 ones that you can hold like a pen. They're not bad for sending pictures to.
Yeah. So either better pictures to us or IDing them on farm. So that's sort of what we're suggesting to people now. So the key is useful, but there's always a but. There's always a caveat. Is because Thrips Parvis finus and Thrips setosus look so similar. When you use our key, you'll get to the sort of like last box, and you'll notice this on the right. And you'll sort of end there, and it'll be like, it could be either one. And then you can't really go any further. So that's when you need to bring something to myself or Judy or Ashley Summerfield at Vineland Research Station, because you actually have to look at more complex features, and you need a compound microscope, not a dissecting microscope.
Ashley lives for this.
Yes. Judy brings her lots of presents, and I'm always like, it's Christmas. So yes, she does enjoy it. So we do need a compound microscope, and they often need to be slide mounted, and some growers we know have purchased compound scopes. They have also gone down in price, but then there is a bit more of a learning curve of like how to slide mount them and what features to look for and things like that. But basically what it comes down to, if you have any interest in tiny features of thrips, is setosus or Japanese flower thrips. Near the end of its butt, it's got little hairs that we call a butt comb on one of the segments, and Parvis spinus does not have that. And then there's also some like hairs coming out of pores on its like mid back that are also happening on setosis, but not parvi. So that's why we went over like the hosts and the damage and the males versus no males kind of situation, because if you want to keep this all on farm, you could use the key to get you to Thrips parvis spinus or Thrips setosis, but then you'd have to sort of use all those other clues to help you decide what it might be. But I would still recommend sending a sample off to one of us.
Yeah. Yeah, like crop for sure will tell you, like if it's mandevilla versus hydrangea,
Yeah,
you know what thrip is going to be.
yeah.
So don't panic. I know how Sarah and I, once we do these, like we get all kinds of panicky emails and texts, but don't panic, because if you think you have Western or Japanese flower thrip, you don't need to lock your greenhouse down. You don't need to go into quarantine. Don't need to panic when you're telling us that you have this thrip. We're not going to send in the paddy wagon or anything like that, because this thrip is easier to control than parvi. We haven't been seeing resistance yet, but if you keep using the same chemistry over and over and over again, you are going to cause a problem for yourself, and then a problem for anybody that's trying to help you control this pest. They do cause less damage. They don't damage the flowers per se as much as parvi does, and they don't cause that corking, distorted tissue that you see with other tropical thrips or with parvi. So, and there is hope for biocontrol, and I'm going to talk a little bit more about some trials that we've been doing.
So just before Judy gets into that, I just want to sort of set the stage of when we do talk about biocontrol for new thrip species, it's important to keep in mind that biocontrol research is very limited for thrips besides Western flower thrips, because that was the predominant thrip since like the 80s that we had to deal with. And it was just so destructive, so resistant to so many things. These are why our biocontrol programs were developed. But that does not necessarily mean that the tools we have developed specifically for this, our number one pest of greenhouse crops, will work for other thrips. I know it's in a lot of similar chemistries work for different aphids, for example, but we know with green peach versus foxglove aphid, we have to pick different different parasitoids. So it's kind of like that. Just because it's a thrips doesn't mean all the things will work for it. So basically, we're at this stage with new thrip species in ornamental greenhouses and veggie greenhouses, where we, might start with your basic Western flower thrips program, but then we have to ask ourselves questions like, do all of these things work? If they don't, we should throw them out of the program and use that money to pay for adding things in. And what could those things be? Are they a little bit more expensive? How do we keep this cost effective? Is there something else we can take out of the regular program? So just as an example, I don't want to give too much away because we're going to do an onion thrips webinar in October, but this is recent data from a grant I was on with Vineland Research on controlling onion thrips with biocontrol. And this is one of their graphs comparing predatory mites for onion thrips control in chrysanthemums. And you can see on the left half of the graph, this is when we put low onion thrips pressure on the chrysanthemums. And you can see that cucumeris, which is a great backbone and staple biocontrol for Western flower thrips, was not different than doing nothing for onion thrips, which is sad. Swirsky, on the other hand, did a little bit better in this scenario, so that's good to know. But then we have to remember onion thrips is one of the thrips we have that's indigenous to Ontario now. So
And time of year.
in time of year, right? So big fly-ins can happen during the summer months. So we also had to do this experiment under high onion thrips pressure, or it wouldn't really be realistic. And in that case, cucumeris still performed the worst. It actually was like worse than the control. And Swirsky statistically was better than nothing. But at 15 thrips per plant, that's still not a good, control. So we did find other programs or combinations of biocontrol agents that did work better for onion thrips, but we had to really play around with it and then also play around with the cost of those programs. So I just want you to keep that in mind as we're moving forward and talking about different thrip species.
Yeah. So step one, always for Japanese flower thrip and any thrip, is to use monitoring and mass trapping. We know, and we keep saying this over and over again with every thrip webinar we do, that you can reduce your thrips population by 30%. It is the cheapest biocontrol that we have out there, whether you're using pesticides or bios. It will knock your population down. So if you have 30% less flying in your crop, it's a no-brainer for me. We know that colors affect certain types. So Western flower thrip does yellow and any really color of blue. Echinothrip, if you have little blue discs that you can stick on the foliage, it'll trap more. Harvey, we know that the dark blue will work all year round, but yellow is cheaper, so it'll work in the summer just as well. And with Japanese flower thrips, I found that the green cards and the green tape are working really well. And you're not going to trap a lot of bios. It's going to be a lot of Japanese flower thrip on those cards. And when you're walking the crop, you can see the damage on the top side of the leaves, which is usually a really nice giveaway for you, because quite often you have to look on the undersides for thrips, but you can see them on the top, and they're very, very active and crawling around the leaf surface. So, usually they're active in the morning. And if you're going to spray, maybe you want to spray in the morning when they're really active.
And I think you mentioned with the green tape and cards that it's almost exclusively Japanese flower thrips you're finding on it and nothing really else. Do you get some flies on there a little bit or no?
Yeah, we get shore flies.
Okay.
And lots of gnats.
Yeah. Okay. but your main pest will be thrips. So that's great.
Yeah, definitely. So the standard Western flower thrip bio recipe is where we started. Like Sarah has said, we start somewhere. So we start with the Western flower thrip recipe, which is Cucumis and Zawirsky for the foliage, Aureus, which is a generalist, nematodes for inside the soil for anything that pupates, and then hypoaspis for what's ever crawling on the surface. And we started there. And we know from research with nematodes that carpocapsae actually performs just a little bit better than Feltii. But does the cost of using just carpocapsae by itself, is it justified? So I don't think so. I like to mix the two. And that way I have bonus protection of the shore flies and Japanese flower thrip larvae as well. So then we ask ourselves, what is Cucumis and Zawirsky doing with the Japanese flower thrip? And so Sarah has...
Do you want to play the video now?
Sure.
Yeah, okay. The video I made when I was at North Carolina State University, it might be the best thing I've ever made. I should just stop my career then, stopped on a high.
Yeah. So, yeah.
So you can see
sound effects are great.
Yeah, so you can see these are second instar Western flower thrips larvae. And as the mites, these are Cucumis mites, come up to them, they can't really eat the second instar larvae because they're too big for them. So the thrips just keep slapping them in the face.
Yeah. And so the interesting thing for me when I'm doing these trials with the recipe, with using Cucumis and Zawirsky, I have found no Japanese flower thrip pupae on the leaves. So I am thinking, because of Sarah's video came to my mind, that this is what they're doing. So again, with the biocontrol program, if they're both doing the same thing by harassing the thrips and making it not a nice place for them to do their pupa, they're going to do it in the soil where we've got nematodes and hypoaspis waiting for them, which is great. And then if they're just there to harass and not actually feed, again, the cheaper one of the two would be my option. So Cucumis is a lot cheaper than Zawirsky. So by taking these mites out of a bio program, I did notice an increase of Japanese flower thrips. So they're doing something, but we just don't know exactly what.
Yeah, and that work I did at North Carolina State actually did show that just the harassment alone reduced feeding damage by around 30%. Because basically, if the thrips are spending too much time slapping someone, they're not eating.
Yeah.
So they don't have enough, energy to develop properly and things like that. So it could just be that factor, or maybe the other possibility is the pupae on the foliage. I mean, they can't defend themselves, so maybe they're actually eating the pupae. I don't know.
Maybe, yeah. I've never witnessed it, but it's something just to sort of, keep in the back of your mind.
Yeah,
they're doing something.
Yeah,
so
we'll figure out what eventually.
Yeah. So then some of the trials we thought, okay, what else can we add to this program that we can streamline it a little bit more to affect the Japanese flower thrip? And so one of the things we look at is the pricing. So lacewings are very cheap. So the Netherlands was doing lacewing trials with lacewing larvae and eggs. They're experimenting with stickers to help the lacewing eggs stick to the foliage. And they're using at the rate of 2 lacewing per square foot or 20 per square meter. In Japan, because they're spraying for other thrips, it is killing off the Japanese flower thrips, so they're still using chemicals. And for Ontario, I wanted to see what the lacewings did directly with the Japanese flower thrip. So I didn't want any other bios bothering my program. I just wanted to see what the lacewing eggs and larvae did. So I did both lacewing eggs and lacewing larvae. And I had some challenges with both of them in what I was doing. So with the results of the lacewing larva trial in Belgium, it worked really well. So they with Chrysopora lacewing that was released bi-weekly controlled Japanese flower thrip just as well as the chemicals. And with the reduction of chemistry in the Netherlands, bios are now becoming more and more the way to go. The lacewing with predatory thrips did even better, but unfortunately, we don't have Vesperformis available in Canada yet. I am trying my hardest to find it on sticky cards to prove that it is here. And once we can do that, then we can bring it across, no problem. So
yeah, they do have it in Florida. So, and they've been experimenting with that for parvi and stuff like that. So
let it fly across the border.
Anyway, taking a trip to Florida.
So if you do have a lot of thrips on your sticky cards, bring them into Ashley and let her have a look and see if we can prove that there's actually Vesperformis here, because it is working really, really well. And again, the Netherlands did 2 larvae per square foot or 20 per square meter. They released it bi-weekly as long as the thrips were seen. And it was a bonus being a generalist that it fed on other insects as well. And as you can see the data with the chart, that the Chrysopa by itself, what they're calling a full field, is actually a greenhouse. So Chrysopa by itself, it wasn't too bad, but when you start putting Chrysopa with the predatory thrip, you got even better control. It was under 50. So yeah, it's the way to go. But right now we just have Chrysopa.
Yeah, and it's the cheapest of the big bios, so that's helpful too.
Yeah, and it's a generalist, so you get a bonus out of it. The optimal use for these lacewings was when the hydrangea canopy was full and touching. It makes a nice little mini microclimate for the eggs and larvae to crawl around. They're not as effective right after cutback on a hydrangea because they're too exposed, and everyone knows that they're nocturnal. So if they have nowhere to hide or get away from the light, you're not going to be able to find them. So when you cut back the plants, this might be a chance for you to go in with a soft spray and then go back into the bios again. So the disadvantages that I have with the lacewing eggs, they're much cheaper than the larvae, and they do better when you're transporting them too. Crops that have smooth and waxy leaves, the eggs will fall off. So it's not as easy to find them in the crop. And when you're releasing at 2 per square foot, it's impossible to find them. So I went with lacewing eggs on cards, and at least I knew where I was releasing the lacewings. But then that made problems with nocturnal beetles and the mice coming along and just eating all the eggs off. And do you think I could catch them? I couldn't catch them.
How nice of you to leave little snacks for them.
I know. And I knew that they weren't falling off from the glue because we laid them on a sticky card with the lacewing eggs in the middle, and they were gone, and there was just antennas and legs left. So yeah, somebody's eating them. They are also very sensitive to chemistry because, as you know, the lacewing egg goes from green to gray, and right at that gray stage is when they pop out of the skin. So if you come along with an oil, you're gonna prevent that from hatching. Stickers also really reduce the you get really poor hatch rates with that, like almost 50% only emerging. So we're experimenting with different rates and different application methods with these stickers to stick an egg, because the idea is to get it into tropical plants and get it up on those big alocasias and things like that. And again, the size of the crop and the leaf canopy. So some other studies, Aureus in the Netherlands as well, they have done a lot of trials with Aureus, and we now know that Aureus works so much better on the tropical thrip species than Western flower thrip, and you can see some data on the chart. They also have a different species of Aureus in Europe as well, but still there was hardly a difference between the two. But Aureus are so much cheaper in Europe than they are here, and we haven't done a trial with just Aureus in the crop by itself to know which rate we actually need for 100% control with Aureus like we've done with Parvi in the past. So right now we're just using the standard release rate and adding it into a bio program. So if you're doing chemical control, if you follow the Parvi rotation guide that Sarah and I did when we talked about our Parvi when we did our Parvi presentation, it'll be in the slide next. It has been working really well on Japanese flower thrip control. Success has worked very well, and so does Delta Guard, but these are not bio-friendly. You can use those two at cleanup at the end for really good control.
Yeah, and Catherine's just going to pop in the link to the blog post I did on this chart, so you can download the PDF if you want and print it out, because I know even on like a webinar screen, this is a little bit small, so you might be like, what am I using when?
Yeah,
So don't panic. It's online.
Yeah. So Sarah and I spent a long time coming up with this chart. We've got 5 options for you, and it'll do all the different stages of thrips. So a bonus is if you're working for Parvis spinus, you're going to get knocked down of Japanese flower thrip too. So just have a look at these. You can print it out. You can have it for you. We've got a good mix of chemical groups. We don't really use 2 sprays the same in a row. And we are targeting different life cycles. So your cards will also help you tell if it's mostly adults or mostly larvae in your population, so you can use the right chemistry at the right time. So some softer options when I was talking about the biocontrol and to incorporate chemistry with bios, and especially at cutback on some crops, and you can still continue with your bio program, is Ference, Lalgard, Sufoil, and Copa. And especially in hydrangeas, if you first cut them back and you want to knock down that Japanese flower thrip population, one application of Ference is working very well, and then follow up with the other chemistries. The Netherlands is having great success using Lalgard, Botanigard, and Copa in rotation, and the coverage is key, of course.
And there's been no phytotoxicity with the Sufoil or the Copa or anything?
Nope, and they've been using, some customers have been using a lot higher rates than I feel safe with.
Oh,
and
nice.
It's been okay.
And on an open blooms too, or just the foliage?
So I would worry about the open blooms with the oils, but Copa's been okay and Ference has been fine.
Right. See, I learned something new.
Mhm. In the summertime when we had the super hot, like you need to do a trial test run first, because it just could be the plant can't handle it.
Yeah.
You come along and you spray them, you're going to get phyto.
Yeah, we've been seeing a lot of weird stuff
Yeah.
when it's that hot. So this is another little summary chart we made during the Thrips ID workshop to sort of, give you a sense of how these different thrips species compared to Western flower thrips like do or don't respond to different biocontrol agents or pesticides. So this needs updating. I just popped Japanese flower thrips in for the sake of this talk, and we need to update the onion thrips one. But anyway, just for the sake of comparison, we can make a better version of this so I can go online later. You can see that Japanese flower thrips, of all the thrips we've sort of touched on today, is probably closer to Western flower thrips in terms of the bios that are available for it and work it. Really, it's just sort of the predatory mites that are sort of like, what are they doing? But it's still like they're probably doing something. We just don't know what they're contributing. And
So working on your other thrips too.
yes, exactly. They'll be doing other things for you. But just if you somehow had Japanese flower thrips only, just keep that in mind. But the benefit of these, this particular pest, if I want to say a pest is a benefit in any capacity, is that not only can we use all the biocontrol strategies we're used to using, but they also are susceptible to a lot of chemicals, unlike Western flower thrips.
Mhm.
But we're always going to go back to the but of
Yes.
like that it's dependent on you
Stop
being
using setosus
responsible.
5 times in a row.
Yeah, yeah. Yeah. So even though, success and pylon, those ones make you feel good because you feel like they're the strongest for thrips. Honestly, like the fact that Judy's even saying one application of Ference works. We did a study with Western flower thrips and onion thrips, and it took, I think, 8 applications to see a reduction in onion thrips, and it didn't really work on Western flower thrips at all when applied foliarly. So the fact that the Japanese flower thrips is fine with one means you don't need to go to these harder things necessarily, unless you have a like right before cleanup, like right before shipping to the States or something like that. You want to make sure that there's no trace of them. So, don't go to the big guns all the time. And that's a lesson we sort of learned with Parvy too, of keeping things like Lalgard M52 and Rimon in the rotation to sort of save the big guns for when you need them. And then also the big guns are expensive. Pylon's expensive,
Yeah.
Contos is expensive, Success is expensive if you use it a lot.
Well, and some of these tropical growers shipping to certain end users, they don't want pylon, contos, success. They don't want any of that on their plants because they will test for it. So we have to be careful how we're using our chemistries because things are coming down the pipeline that might force us to only be able to use bios. So we have to really be careful with resistance.
So just one more thing to add in when we talk about integrated pest management, our brains automatically go to biocontrol and pesticides, but there is more to it. Biosecurity is an important factor, especially when the call is coming from inside the house. And what I mean by that is these exotic species, they're not blowing in from outside. We don't think they've necessarily established here. If Japanese flower thrips has, it would be at really low rates right now. So all these other thrips like Thrips parvispinus and palmy and things like that, they're coming in on your cuttings, which means you probably should start experimenting with dipping both unrooted and rooted cuttings of hydrangea, especially to see if that will work. Because we know with Parvy, that's such an important tool to reduce the incoming population. So preliminary data with parvispinus has shown something like Cefoil X at a rate that won't cause phytotoxicity can reduce your incoming population by around 70%, which is very similar to the results we got with Western flower thrips. I suspect the same would be true of setosus. It would just be a matter of finding the right dip that doesn't cause phyto, but so far Cefoil X has been really gentle, and obviously the dip rate is way lower than the spray rate. So the other thing to consider besides dipping your own material is considering your workflow. So like spread from within the greenhouse. If you have, a range of hydrangea that is chock-a-block full of setosis, you don't want workers going from there into a different part of the greenhouse where there's a new or younger crop, or maybe even any of those other hosts on the host list that we mentioned, because if a thrips is given an opportunity, just because we're like, maybe isn't such a big pest on these, if that's the only thing they have around in the compartment to eat, they may become a pest. So you don't want to find out the hard way that no, they will eat chrysanthemums just because your workers are sort of bringing them in on their clothes and things like that. So keep that in mind. Biosecurity, I believe in it after parvispinus especially. And then Judy and I both have had thoughts about like, okay, well, where do we go from here? So we do need to confirm things like the host range in Ontario, the crops, but also non-crop plants, because we know parvispinus can feed on weeds and is probably reinfecting some of the crops in the greenhouse, or certainly not helping. They're acting like little free banker plants for the parvispinus. So the same might be true for setosus, given their broad host range.
In the spring,
Yes.
this is where we found a lot of Japanese flower thrips showing up on annuals because we had another crop below and you got the baskets hanging up. So.
Yeah. We should confirm if it's been established outside, but that might be work for a little later down the road. And then we basically just need to still figure out best management practices for monitoring bioprograms and pesticides. Like Judy's been doing amazing work taking like what we know for other thrips pests and putting it onto this, but it doesn't mean we aren't in a phase where we still can like pull some stuff out, add some stuff in, make it a little better, make it a little cheaper. So we need to keep working with our grower collaborators to do that. And then a lot of work is happening in Belgium by the BioBest group, which is great. And then also
more trials coming next year.
Yeah, more trials. And then Judy, I mean, you might as well just call me Sticky Sarah at this point, because like I'm with Judy. I'm like a Sticky Card fan. So along with sticky cards, are there other things we can do, like add lures? Can we look at trap plants that they especially love and sort of suck them out of the crop onto more cards? I would love to investigate that. And then lastly, we talked about some of the pesticides that are available for Japanese thrips. If that sort of felt like it was coming at you fast and hard, I have added Japanese flower thrips to Ontario's Crop Protection Hub, and Catherine will add the link to the greenhouse ornamental module of the hub into the chat function. If you're not familiar with Crop Hub, then I did do a webinar on it a little while ago. That wasn't my best webinar. There was a lot of technical, of course, there was technical difficulties when I'm trying to teach you about a new tech tool. But that is on the On Floriculture YouTube channel, so you can look that up and just bear with the technical difficulties. So that's a good place to figure it out.
It's a very good resource.
Yeah, thank you.
Yes.
And obviously Judy knows what chemicals work, so obviously, feel free to shoot anyone at Plant Products an email. And then this tool also includes what we're seeing in the field with efficacy too. So, and then lastly, I just want to make a plug for our next couple of series in the series of thrips that aren't Westerns. So I'm going to talk about Parvis spinus in September. It's going to be very similar to the talk I did at Greenhouse Canada's Grower Day, but not everyone was at Grower Day. Also, I was sick, and I felt like maybe it wasn't the most comprehensive talk.
She did okay.
So I'm going to turn that into a webinar. Thank you, Judy. And then we're also going to talk about onion thrips because we have a lot of great research there. So that's going to be with people from Vineland Research and Innovation Center and also other OMAFA people that were involved. And with that, we will take some questions as soon as I stop sharing. Which, no, so you working?
There we go.
Yeah. Okay.
There you go.
Perfect. Thanks so much, ladies. That was awesome. We do have several questions, which is great to see. So our first question is what to do if I find/idea it in my crop in Ontario?
Just call one of us and we can help you start a biocontrol or chemical program, because it's really going to depend, like what you're going to do is going to depend what stage the crop is in, where it's going, how bad it is. So I think,
where you're selling to, and make sure it is that Japanese flower
Yeah.
for you first.
That's true. Yeah. Step one would be confirming it for sure.
Yeah.
Perfect.
But don't panic.
But don't panic. And there's no,
don't
and it's not, because it's already been ID'd in Canada,
Yeah.
there is no, like you don't, when you find something, a pest for a first time in Canada, you're supposed to send it in for identification and alert CFIA, but that's already happened. So there's no burden on a grower right now to alert anyone, if that makes sense. So like we're here to help. And we're not like the bug police.
Yeah.
Okay.
And you can, even still, you can drop off the samples anonymously to
Yeah.
our work or to Sarah.
I have a drop box outside that's
Yeah.
very dirty right now. I apologize. It's been living out there for 2 years, but I will clean it up. It's a little Tupperware container like outside our Vineland research station. That's my anonymous drop box. So as long as there's some way I can reach you on there and let you know what the answer was. Yeah, we also have that if you're uncomfortable for whatever reason having government come in your facility.
Yeah.
So next question here. So more pupae on leaves. Is there any experimenting/results with nematodes on foliage?
So we have been doing the carpocapsae and feltia, feltella trials, and there is a higher percentage of kill with carpocapsae than there is with feltii, but again, it may be like 5 to 10 in the number difference. So I like to mix the two together and it's like you apply it through a foliar sprench, which is a heavy drench, and it runs down. And if it's the hydrangea have a fairly, or the tropicals have a fairly, nice touching canopy, then it keeps that environment and that humidity up so that the nematodes actually have time to get into the insect's cuticle.
Yeah, so think of it more as like a washing them down, because there's been lots of work that Rose Boughtonhouse did on foliar applications of nematodes for like Western flower thrips and stuff, because Western flower thrips will pupate not in the soil too, sometimes at high levels, but it's just not that effective because they can dry out really quickly. But if you're thinking of it as like, okay, I'm washing the PP off and everybody's going in the soil and everybody's going in the soil with a wash of nematodes, I think that's the best way to think about it.
Yeah. And a long time ago, all we had for really Western flower thrip was nematode using foliar applications. So, but now we've got more bios and we can reduce the cost that way. But they will work, but the humidity is key.
I think you ladies might have touched on this, but have either of you noticed predatory thrips, example, Aeoliothrips or aureus feeding on Japanese flower thrips?
Yep.
Yeah.
Yeah, there's a lot of Aeoliothrips right now coming in the greenhouses from outside, and I get so excited when I wish we could propagate them here. I keep bugging BioBest. But
yeah, there's just nobody producing those commercially, but maybe in the future.
It's hard to rear them. I get.
Yeah. Yeah. So we do need, that's the problem, is like there are these predatory thrip species, but you have to find one that is sort of amenable to being commercially produced. And then the other thing I do think with the border, that is going to have to be like an educational, if we ever went down that road, it would have to be an educational thing, right? Because then they'd see these other like scary thrips, and then we'd have to convince people that that isn't a pest thrips. So it's not a simple.
Yeah, Vespiformis is very big.
Yes.
Yeah, and Aeoliothrips are very big. So yeah, people can see them without a hand lens.
Okay. The next question is about eggs. Have you tried broadcasting CC eggs on wet foliage to stick them? Guess they still fall off after drying, question mark.
Yes, and that's what we've been working with, some different stickers and coming up with the best, like a 10% solution, 8% solution, and all the way down to like 0.5 to see what that magic number is to make them. We know it sticks. We know the eggs get through there, but then we're trying to get a good release rate. Like it's knocking off the population too much. Like if you put 100 eggs in, you're only getting 50 that hatch. It's still not. It's a cheap bio, but you still don't want to put in double what you need. So we're working with that.
Do we know if Japanese flower thrips can transmit INSV too?
I don't know if we know that. I don't see why they couldn't, in the sense of, Western flower thrips can transmit a bunch of different viruses. So yeah, I think that's a good question.
I think it was just found in vegetable crops. That's why I said tomato spot wilt virus, but probably we haven't found any virus in ornamental crops yet for INSV. So,
and like I've never seen parvi transmit a virus either. So I think it could go either direction. Like
we need to get some globulinias and see.
Yeah. Feed them tiny little viruses.
Yeah.
Okay. Sorry. If the population is mostly female, will pheromone trapping males be feasible in the future, assuming JFT becomes enough of an issue to make traps economical to produce?
I think with the traps, you would want to go with the plant defensive compound ones and try to attract the females, because the females can just produce more males to mate with. So it's like this, in that sense, the sex pheromone won't really work. In the same way it would for Western flower thrips, where the ratio is like the same. Well, it depends what the sex pheromone's attracting the females and the males, but
10% males to a 90% female population.
Yeah, it probably doesn't make sense. So, and you have to remember it's the adult female, like for example, Western flower thrips, one female produces 300 eggs in her lifetime. So it's really about trapping the females. So I would say I'm hoping some of these general thrips lures that are based on like methyl salicylate and other defensive compounds will be the ticket. And then it would be great if you have other thrips in your greenhouse and you have like one ring to rule them all, like one lure to rule them all. Would be nicer than these specific sex pheromones, and those take a long time to develop. I'm like, it'd be nice if we had one for parvi, but like so
maybe because parvi especially is costing a lot of money, so maybe the research will be there to make a specific pheromone.
Right. Okay. I think we have time for one or two more questions.
Yeah.
So have you used low volume misters for applications of either bioproducts or chemistries?
Yes.
Yeah.
Mhm.
I
And pretty
was
much
gonna,
everybody, even though it doesn't say it on the label, has tried low volume misters for sure.
So my rule of thumb with that is if you're doing a pesticide, and Judy can chime in on this, obviously, to always start at a third of the label rate because you can have higher phytotoxicity running it through an LVM because you are essentially getting more coverage, more is landing on the crop. So start there and work up. I'm sure there's some chemicals where people can do like a rate safely, but yes, it's technically like it's not, unless it specifically says you can run it through an LVM on the label, it's like not an application that is recommended.
Yeah.
Yeah, be careful. The point is, if you're going to do it,
And
even
test.
if be,
Oh my
be
gosh,
careful.
test.
Yes, test it.
Watch your temperatures.
Yes.
All kinds of stuff. Yeah.
But
Yeah.
microbials, yeah, especially like
Yeah.
they can help get on the underside of the leaves.
I believe there's fogging on
Yeah.
some of the labels on
Yeah.
that, but
And then it helps penetrate the canopy. So it can be a really good tool. It's just like use it appropriately and in a perfect world legally.
yeah.
Okay, there's one more question in the chat here. Not sure if I missed this, but do you know if we have some products for controlling eggs, or is there a way to control that stage?
That's what we're looking at the dip for. So right now, the Vineland Research and Innovation Center, the grant we're partnered on, that's why we're looking at things like, do these dips, like in soft-oil or what have you, affect eggs? Because most of the work that's been done up to now has been either looking at larvae and adults separately or the population, but it hasn't specifically gotten to the question of like how many eggs we're killing. And there is a theory out there that the oils would affect the thrips eggs more because they're embedded in the leaf tissue. So like maybe getting in that little hole they're in and suffocating them before they come out. But we don't really know the answer to that. So Vineland's working on that. I think at the Canadian Greenhouse Conference, they're going to be presenting more of that work. I've seen some preliminary data, but I don't want to say anything right now because it's a little too preliminary. The other thing that we've been looking at for Parvis vinus, which probably won't work for setosus because it's a cold weather thrips, is parvi being a tropical thrips. We're looking at cooling the cuttings to potentially reduce egg hatch, and that is showing some promising data. Some preliminary data is if you hold them around like 4.5 for 3 days, you're reducing the incoming eggs by 70%, but that's parvi, which likes it warm. So I don't know if the cooling cutting would work for
I don't
setosis.
think so.
Yeah.
Because it overwinters in our coolers. So
But there's other there's other things,
Steam.
technologies, UVC.
Yeah.
Somebody was talking about
Nitrogen.
like agitation, like sort of
Yeah.
Anyway,
there's all kinds of different ones. Maybe we'll have an update next year.
yeah, I'm pretty sure we're going to be working on dips for
Yeah.
life in Canada, considering we get so much of our material imported from other places with the pests on them. So yeah, I think that's a good avenue.
Okay, and we have one more question here in the Q&A. Can Exirel show the same efficacy to ferrets on ornamentals? They both have the same active ingredient, but different concentration. Exirel being cheaper, even when comparing concentration to price ratio.
That's really a question we can terribly answer, but
well, Exirel is the ag version of
Yeah.
ferrets, which is the greenhouse version now. And price per active ingredient is actually the same, but ferrets is a more concentrated bottle. So price is exactly the same for ferrets and Exirel now on our
well, there you go. So we can't answer the question
because we fought back because they were with the producer because our customers found out that Exirel was cheaper, and so they asked why we weren't selling it, and we said it's a price point, so they changed it.
Yeah, so in this case, yeah, that makes a lot of sense. And just a reminder, I don't want to, end this webinar on a downer, but sometimes if we fight to get registrations of products on ornamentals specifically, and then nobody buys them, then they like go away and everything that we sort of fought for, then it's really off label, right? So like we do have to sort of keep that in mind. And I know it's hard when there's like a huge price discrepancy between the field and the greenhouse one, but remember people like plant products are fighting for you, and that sense to make it sort of more equivalent. So just keep that in mind.
Yeah. So to be legal, use ferrets inside. Please. Or say you're using it.
Okay, I'm not seeing any more questions coming in on the Q&A. So I think we'll leave it there for today.
And
But
thank
thank you.
you, Judy, for being a wonderful guest for on floriculture. And thank you, Catherine, for hosting your only second webinar ever with OMAFA. I'm sure you guys will be seeing more of her in the future. So with there, yeah, everybody have a great day. And if you want to see this recording later, it'll be on floriculture.
Forever.
Yeah, forever.
Forever.
Okay, bye, everyone.
Bye.
Okay, thanks everybody. Bye.